Good afternoon. I am Sivarama Prasad, visiting faculty at IARE. Today we'll look into a fabrication model development, mainly focusing on reverse engineering. Reverse engineering is one area where it is very useful in the industry. Because when industry is always striving to serve the market by offering products, fabrication is the major activity, and product development, product design, these are very, very important. And in that product design, product manufacturing, design is the starting point. In the design also, there are two major methods. One is forward engineering, that is a regular engineering development process. Another is reverse engineering. Reverse engineering is done when already there is a product, but you have an interest to do it, but you don't want to spend too much money, or you don't have a time to develop. At the same time, you don't want to start from the zero base. You will take it like a relay race. At some point, you take it and take it forward, something like that. So what actually is reverse engineering? If you see the process, instead of analyzing the old one, you will take a product you already have in a mind. You construct that, and already there are some full-fledged products, or you may not be having it. You will take it, you study that product, and you will analyze it. Then from that, you create a product, a similar or a better or totally new one. Here, where it is different from the forward engineering is, you are not going to the customer need, and from there trying to convert into an idea. From there, think of a process, think of a feature, think of a function. You are not taking it. There is already a product which is serving the need. That product you will take it. That means you will avoid few initial steps. That initial steps, sometimes it is easy, sometimes it is very difficult. So many people will start from reverse engineering also. But there are many occasions where reverse engineering is very, very useful, important, and sometimes it is very critical also. Suppose that you have a product, you want to improve the design. It is required, because you have to find where there are some loopholes, some defects, some discomforts, whatever is there. That is one. That is as a redesign. Then sometimes what happens is, already there is a product and you will just want to do it one more product, a similar one. And third one is, you have to take the product, you have the product, but you don't have any drawing when you want to remake it. With one drawing, you can, if drawing is there, you can make it. There is no drawing, there is a product. You made 1,000 numbers, 1,000 numbers is over, the last one is there, 991. That last 10 numbers, they are there. What you will do? You have to create a drawing, you have to create a documentation, and you have to create a computer model. Otherwise, you cannot make it next. Sometimes what happens, you have to make the product, even with the company itself, to duplicate it. Suppose you have created from your old heritage product is there, and there is a lot of demand suddenly. You want to make it, there is no drawing. So you have to create that. And some other case, if you go into the plant and equipment, machines, something is as a spare you require, but you will not be able to locate that. You bought the machine about 5 years back, 10 years back, Today that supplier is there or not, we don't know. And that man is making or not, we don't know. And whether he is ready to supply or not also, we don't know. At that time, there is only one alternative: is you have to create a drawing from the existing, then you have to make it. And there are some other cases where product is there, drawing is there, everything is there, but it is not updated, and you have to make some changes now because you thought this will work. After launching in the market, it is not working. Then you have to change it. But in the process, during the trials and all, you will be doing a lot of corrections in the tools, components and all. Whether you have upgraded, updated the drawing or not, we don't know. Because in that urgency, you may not update also. At that time, you have to make it. You have to change. You have to remake it. Some area, you have to change it. That is one area. And after launching, you have found some bad features. After 1 year or 2 years, something is breaking, something is excess wear. These things also there. And another thing is, you have a competitor product. You want to benchmark it, understand that, and then do a redesign. In some other cases, you yourself want to improve. And in all these cases, it is a basic need in the industry. It is not that they want to do just like a fancy. And another way is, suppose you want to give it a student an innovative project or a critical thinking product. You can give the product. From that product, he will analyze, he will find, and he can create some more products from that. All these things is making reverse engineering a very, very important activity. And especially when there is no drawing and when you want to create it and you want to make it, it is a bare need. And when you want to improve on the existing, it becomes one of the major activities in the industry. And some are like patents, so that you will do it. Some as a premium products in heritage, you want to do it. This is one way. For example, if you go back about 10 years back, ceramic tiles have come. At that initial level, they were very smooth, very machine oriented, polishing. It was looking very nice. But people have started telling, you don't get health benefit on that. It slips. A lot of people fallen on that, broken their legs, hips, like that. So, someone innovatively wants to make it better. This actually happened also. One Italian or one European man came to Mahabalipuram in Chennai. He was seeing the natural stones and he read the data that natural stones are good for health and it gives a lot of blood circulation in the feet and all. Then he saw the granite stone. He took a piece of it, about 1 foot by 1 foot or 2 feet by 2 feet, like it, and he carried it. He reverse engineered that. And then he converted that into a drawing. And then it is put into the ceramic tile finishing. It gave the same pattern like the natural stone. And that is how you see nowadays some bathroom tiles and anti-slip, anti-skid, some tiles which are creating such patterns. This is one of the very, very innovative way of bringing that reverse engineering into an activity. And this is how the product or the reverse engineering, the name has come. That means you are doing it, reversing it, and then creating a new engineering from that. But in this case, you have to see, and you should be careful about sometimes the patents, the copyrights, or IPR, these things. It is not that it will attract. There is a chance someone getting into this. So be alert. How you would get into these process steps? First, you will identify the product which you want to do it, or which you are selecting it. Then you have to create a lot of questionnaires on that, observations. You have to make a list and interact and collect the data about that product, about how it is behaving in the market, how it is used, and how the function was there, whether there was any problem or it is lifelong good. All those things you have to do it. Then, as a product, like a new designer, you should predict something: the purpose, the function, assembly sequence, working design, and how it's going to help the customer. All those things you have to predict. Then, with this product, you have to check all the things, whichever you thought of it from the beginning: how it is working, what is the function, test it, how, with reference to the specification, it is there, what are the parameters to be controlled, what is the estimate on the manufacturing. And you have to do like a regular product and take photographs, as many as possible, and then collect notes, whichever minute thing, image or point or observation, everything you have to do it. And all these things you have to do it before assembly, before disassembly. Once you come to a disassembly stage, that means at that time you have the entire data of the product. That means dimensions, functions, finish, and whatever test parameters, everything. Now you have to disassemble that. When you are making disassembly, you have to be very careful. If you take one sample, suddenly if it breaks, that's all. So you should have in the store about 3 to 5 samples, so that one you will use it for this, one you keep it as a master, one you don't dismantle, one it will be with R&D, one you will use it for people to study and do that. And one by one, you make a process of disassembly, and one by one you dismantle it until you get to the last final child part, where that is the final one. And in the process, you should be very careful. Wherever there is adhesive, some moving parts, non-moving parts, you have to break open, or some glass items or some care items, some items where there is liquid which you have to protect. These things you have to be very careful. And while dismantling, you dismantle it and make it observations stage-wise. Or if it is possible, you can record it through a video or take pictures, make notes like that, because you should not miss anything. Tomorrow, you will not again, you can remember. Sometimes what happens is, you dismantle everything, and when you assemble it, still product is assembled, 2-3 parts will be there. You have forgotten where to fit it. That should not happen. And as you remove it, you are making all the things and making the bill of materials. Then, with all the items at your hand, you will make a bill of material as if it is a new design. Parts, make a assembly drawing, sketches, preliminary drawings, and then start taking measurements. For measurements, you have to see different measuring techniques. Coordinate measuring, CMM, or scanning, or profile projector shapes, or general dimensions and tolerance. You have to make it, and from that you have to make a full-fledged drawing. That means with this drawing, with this software data, you should be able to make a new design. Forget about that, whatever you have done earlier. This is the starting point for the new design. And here you have to analyze and create a data completely like a real design data. Once you make this design data, reassemble that. After reassembling, you should see whether it is matching the original one. And after the matching, you should see whether the function is given, whether you have missed anything, whether there are any leftover, or while fitment or while dismantling you have found any abnormal things, or while running, how is the performance. And you have to get all the data. Then conclude on the design, manufacturing methods, everything. Documentation is over. Now, from the document, you make a product. That proto, it should be same as this. It is like a creating from one, dismantling it, creating a drawing, and then from that drawing, you are creating a new generation birth, giving a new birth to a new product, and you have to compare this first product and this what you made, how they are correlated, how they are working together, whether it is same or it is improved or it is degraded. You have to analyze. With this, you get into the product, come to a R&D stage where you say, yes, this product is what as per plan. It has satisfied whatever way you have planned. It is better than this. It is improved in these areas it is there. Then it goes into a regular product development. Regular product development is same whether it is for forward engineering or reverse engineering. Only advantage here is you have a product to see. That means if you have a doubt, you can see it. Whereas in the regular forward engineering, it is all concept and only the model, only the designer has got the physical visualization. Nobody else can really think of it. Whereas here that there is an advantage that everybody can see how the product should look and everybody will work for improving that or looking it better. Just as a pictorial way, if you see, suppose you have an iron box. You want to reverse engineer it. What you will do? You follow the process, dismantle it, get the dimensions, take the finish, everything you create like a model and as a new design. Then you make one model from that new one and that manufacturing drawing, you go to the process, then you make a physical product from this. This is on the product making. As I told you, sometimes you have to duplicate, you have to do corrections. These are two examples which are live examples which I have taken. One is in a automobile, the door, when after making it, you will check it, whether it is shape wise the same, function wise same, or dimension wise same. When you are checking, that checking fixture, it gets worn out. And over a period, you see today if you see cars, every year they are making in lakhs. So this gets worn out and after 1 year if you see the dimensions, it will accept everything. And if you fit it in the car, it will not fit. You will find a lot of rattling or sounds or gaps. So you have to duplicate this fixture. When you have to duplicate this, you should have the drawing data. It is a 3D model. That means it will have different shapes. You have to make it means it is very difficult without a drawing. At the time, you have to create data from the existing and superimpose the product. Then you have to create your own drawing. Then from the drawing, you have to make it. Here, the reverse engineering is one of the most very, very useful one. You can tell there will be drawing for that. You can make it because you see, for example, today a car is there, which is made about 5 years back. Drawing, sometimes you will not be able to access that. It may be done in Japan or US or Australia or Europe. From there, you will not be able to get the drawing today. If you ask, I want a drawing for this, means you will not have. Or even if you have a drawing, in the process of 5-10 years, you would have done a lot of modifications. So it will not fit. So you have to take existing, whatever is available. From there only you have to duplicate it. Here the duplication is not a wrong word. Because you have to duplicate it. Otherwise you cannot run the next there. So here it is one method. And in some other cases, you have made a big roof or the bonnet or sidewall. And during the process, you have to change the handle. Instead of fitting it here, you have to fit it in a reverse way or a different way. You have to add some holes, some shape. You have to do it with all the tools, very big tools. There will be like the size of 3 meters, 2 meters like that. In such, you have to get the drawing. You will get the drawing. But the doubt is whether it is updated or not. Nobody can give a guarantee. If you have taken it for granted, you may end up in a mistake, and that mistake you cannot irreversible. You cannot correct it back. It goes as a waste. And if you want to make a new tool, it takes another 6 months. So nobody will take that risk. So what you will do? You will take the existing tool. You will take the measurements from CMM, scanning, laser, all those things. Then whatever way you want, you create one more drawing, and with the drawing you do the modifications. These are two important things. Day in and day out will be happening in the industry. So that their reverse engineering, without reverse engineering methods, it is impossible. My personal experience, about 20 years back, when you want to do one duplication, there was no CMM that time. There was no laser scanning at that time. Luckily, we were able to go to a person who brought one R&D equipment from USA and keeping it idle. He is a doctor. He doesn't know how to use it. Then we took this, laser scan it. From there, we generated the drawing. Then we started. After 2 years, everything has come to India. So today it is not a problem. But that time, we were not able to do it. If you want to buy it from the original manufacturer, he was asking 1 crore. Because he has scrapped it. From old, he has to take it back. Means he says it requires that much money. We cannot spend. So these are all some of the emergencies and life-saving. This reverse engineering will help. And if you see the reverse engineering or engineering as a comparison, engineering starts with identifying the need, creating a problem statement, or from the problem getting into a solution, from the solution getting into a design, from the design getting into a prototype, from prototype testing, evaluation, then finalizing the design. Here what happens is, you don't get into all those things. You take the product which you want to select. From that product, obtain the dimensions, break it open, scan it, create your own 3D model with changes or without changes. Then make a proto, create a sample. From that sample, again you get back into regular manufacturing method. These are two important things. When you are generating new, it is engineering design. When you are generating from the old, but you want to improve it, then it is a reverse engineering. This is how this component is made, or this is used. This technique is used very, very useful. And every maintenance man will love this, because for him, he cannot get drawings. And every tooling man, he will not get all the drawings, and he will always have a doubt. He cannot recorrect it. So when he wants to be very sure, you take everything on your own and you reverse engineer and get confirmed, then you do it. This is how this process has become very, very useful in engineering field, especially in the practical industry. So thank you. And this way, you have to create new methods into this by creating these 3D models and all. Today it is a very laborious process. We can add our value by making it much simpler with some innovative methods, creative methods, new technologies. All these things you have to bring it into this. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.